Formula for time period of mass spring system is given by 2 pi times square root of the quantity m over k, where m is mass of the block and k determines spring stiffness. We will look at this formula conceptually and try to develop physical intuition. Let's look at the setup first. This x equals 0 marks the equilibrium position of the system when the spring is relaxed. Right now in the picture, the block is pulled to the right. When it will be released, it will oscillate between the two extremes marked in the diagram. Restoring force is provided by the spring. What parameters can we change in this system? We can make the block massive or lighter. We can use a softer or stiffer spring. We can pull the block less or more from equilibrium. Let's see the effect of changing mass on the time period. We use same springs and pull both the masses same distance away. Only differences in the masses of these two blocks. Same displacement means same spring force by Hooke's law. Same force on different masses means different accelerations. Bigger mass accelerates slowly. It does not speed up as much as the small mass. So it takes more time to cover same distance. Thus, period of bigger mass is more. Mass and period are directly related. If mass increases, period also increases. If mass decreases, period also decreases. How does spring constant affect time period? We use same blocks and pull both the blocks same distance away. Only difference is in the stiffness of the springs. The lighter spring shown here has small value of K, meaning it is a soft spring. The darker spring shown here has larger value of K, meaning it's a stiff spring. Same displacement of different springs mean different spring forces by Hooke's law. Different forces on same masses means different accelerations. Mass with stiffer spring accelerates faster. It speeds up more than the mass with softer spring, so it takes less time to cover the same distance. Thus, period with stiffer spring is less. Spring constant and period are inversely related. If spring constant increases, period decreases. If spring constant decreases, period increases. What about effect of amplitude on period? We use same springs and same masses, only differences in the amplitude of these two blocks. First block here is pulled a small distance away from equilibrium. Second block here is pulled farther. Different displacements of same spring means different spring forces by Hooke's law. Different forces on same masses means different accelerations. First block has smaller acceleration, so it moves slowly, but it also has to cover less distance. It so happens that less distance compensates for smaller acceleration and time period is not affected. Similarly, the second block has bigger acceleration and moves faster, but it also has to cover more distance. Here again, more distance offsets higher acceleration and time period is not affected. Amplitude and period are not related. Amplitude has no effect on period of the system. That is why amplitude does not show up in the formula of period. So the conclusion is, period is directly dependent on mass. That's why mass is present in the numerator here. Period is inversely dependent on spring constant. That is why K is present in the denominator here. Period is independent of amplitude. That's why amplitude is not present in the formula.